Morning, children. Let us continue the ninth standard physics lesson, chapter 10, Gravitation. Today, let us learn a new topic called buoyancy. What is this buoyancy? To understand this, let us consider an activity. Take an empty plastic bottle. Close the mouth of the bottle with its cap. Put it in a bucket which is filled with water. What do we observe? We observe that the bottle floats. Push the bottle into the water. You feel an upward push. Try to push it further down. You'll find it difficult to push deeper and deeper. This indicates that water exerts force on the bottle in the upward direction. The upward force exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. Now, release the bottle. It bounces back to the surface. By this activity, we can understand that this buoyancy is an upward force exerted by the water on the object. And this is called as an upward force, or it is called as buoyancy. And buoyancy depends on two factors, volume and density. It depends on volume of the object immersed in liquid and density of the fluid in which object is immersed. The next topic we are going to learn is, why does objects float or sink when placed on surface of water? To understand this concept, let us consider an activity in which take a beaker filled with water. Take an iron nail and place it on the surface of the water. What happens? We observe that the iron nail sinks. Right? The reason is density of an object. Here, density means mass divided by volume. The object I considered is the iron nail, and hence the density of an iron nail is more than water, and hence the iron nail sinks. Consider another activity in which take a plastic bottle. Try to immerse it in the water. What happens? Whether it floats or sinks? Yes, it floats, right? The reason is the density of a plastic bottle is less than water, and hence the object floats. Therefore, density of an object is more than water, then the object sinks. When the density of an object is less than water, then the object floats. Next, we shall move on to the topic Archimedes' principle. Archimedes was a Greek scientist. He discovered the principle, subsequently named after him as Archimedes' principle. To understand this Archimedes principle, let us consider a stone which is tied to a thread. Take a beaker filled with water and try to immerse this stone into the beaker filled with water. That is, when a body, here I consider the body that is a stone. When it is immersed fully or partially in a fluid, fluid means water. What happens when you immerse the stone into the beaker filled with the water? The stone experiences an upward force by the water, which means that as we immerse this stone, the stone has certain weight. Then equal weight of the fluid gets displaced, and hence Archimedes' principle can be stated as, when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Now, consider a problem based on these concepts. The problem is that the volume of 500 gram sealed packet is 350 centimeter cube. That means mass of the packet is equal to 500 gram and volume of the packet is equal to 350 centimeter cube. The question is, will the packet float or sink in water if density of water is 1 gram per cm cube? Initially, we have to find out the density of the packet. After getting the value of density of packet, we need to compare that value to the density of water. Then we have to say whether the packet floats or sinks in water. To do this problem, first let us write the given part. Now apply the formula of density, that is equal to mass divided by volume. Substitute the values. Mass of the packet is equal to 500 gram. Volume of the packet is equal to 350 centimeter cube. What happens in the next step is that 0 of the numerator and 0 of the denominator get cancels. The remaining value will be equal to 50 divided by 35. It goes by 5. 5 tens are 50. 5 sevens are 35. That will be equal to 10 divided by 7. Now perform the division. 7 ones are 7. The remaining is 3. 3 is lesser than 7. Take one decimal point. Put 0. 7 fours are 28. You get the value equal to 2. Again lesser than 7. Take 0. 7 twos are 14. The remainder will be equal to 6. Therefore, the density of packet will be equal to 1.42 gram per cm cube. Now, compare the values of density of packet, that is equal to 1.42 gram per cm cube, and the density of water is 1 gram per cm cube. Therefore, we can come to a conclusion that density of packet is greater than density of water. So, when the density of an object is more than water, then the object sinks. Therefore, in this, the packet will sink in water. This is all about the lesson gravitation, children. Thank you.